Hello everybody, and welcome back for those of you who are joining us again, and welcome to those of you who are joining us for the first time. This is the First Thursday Club that RSK Biocensus hosts, and today we're going to be hearing from Dr. Pete Walker, who's going to be talking about weirs, I assume from the title. But before we get on with that, I've just got a few housekeeping notes to go through. While the presentation is going, we're going to have everybody on mute for obvious reasons. But there is a option for asking questions in the panel, the control panel. So you can ask those questions online. They'll be sort of stacked up, and then at the end we'll have a Q&A session. Any questions that we don't get around to answering today will be answered via email probably from Pete or somebody else in the team. The final thing to say is that after the presentation, at some point you will be emailed with a questionnaire. It would be great if you could take some time to fill that in. It helps us refine what we're doing here and make things a bit better for the future. But without further ado, I'll hand you over to Pete, who's going to talk about where there is a weir, there's a way.
Okay, thank you, Tim. Oops, sorry, something just happened on my screen. We'll ignore that. So just a quick introduction to myself. So as Tim said, I'm Pete Walker, an Associate Director at RSK Biocensus, and I head up the aquatic ecology side of things. I've been an ecological consultant for about 12 years, predominantly specialising in freshwater ecology with particular interest in fisheries ecology, including fish passage, which is one of the topics of today. And I also have an interest in other things, including invasive non-native species. Prior to becoming an ecological consultant, I was a research scientist, worked at several universities, both in the UK and abroad, with a research interest in fish parasitology, sustainable aquaculture, and freshwater ecology generally. So I did bits and pieces with fisheries ecology and macroinvertebrate ecology and that sort of thing. Just a little bit about RSK Biocensus for those who don't know about us. So we class ourselves as one of the leading ecological consultancies in the UK. We've got an in-house team of about 80 people spread across 10 offices throughout the UK. If you see the map there on the right-hand side, you can see the little pink dots of where we've got our different offices. Back in 2009, Biocensus joined RSK's existing ecological team, and that formed RSK Biocensus, and that brought together both the in-house expertise at RSK and at Biocensus, and also gave us access to the UK's largest ecology skills network. And again, looking at that map there on the right hand side, each one of those little green and white dots that you can see represents an ecologist that's one of our approved subcontractors. So they all go through a vetting process. We get a copy of their CV and that sort of thing. And they've all got various different skills. So you can see from that we've got an exceptional UK coverage, something quite unique to our organisation. We've got lots of sector leading ecologists with expertise ranging from fish to badgers, and including people with expert witness and public inquiries experience. So in terms of aquatic ecology at RSK Biocensus, I'm just going to run through a few of the different things that we can offer, and then we'll jump into the fish passage presentation. So we cover predominantly freshwater, but we've also got expertise in estuarine environments and marine environments, and indeed we've got projects ongoing in freshwater, estuarine and marine environments. There's also a marine team at RSK that we work quite closely with, and again they have some very good expertise within that team. We do habitat surveys, whether that's lake habitat surveys, river habitat survey, the RHS, or walkover surveys using, for example, the Hendry Craig Hine method. We cover all those sorts of things, as well as more in-depth habitat assessments such as HabScore. And recently we developed a rapid habitat assessment tool specifically focusing on eels together with the Environment Agency. We also cover water quality surveys and take pollution investigations, hydrological investigations including flow gauging, protected species surveys. For example, white-clawed crayfish, we've got license holders for those. Invasive non-native species surveys, whether that's plant related or fish related or invertebrate related, killer shrimp, invasive crayfish, those sorts of things. macroinvertebrate surveys, diatom surveys, fish surveys using a variety of different approaches, whether that's electrofishing, seine netting or fight netting, and again in all sorts of different environments. And we undertake fish passage and screening assessments. I put my email at the bottom there if anyone wants to take a note, but I think you all get a copy of this presentation afterwards, and my details will be at the end, so don't panic if you haven't managed to scribble that down. So what are we going to cover today? I'm not going to read through all of this. We'll come to each section as we get there, but I'm basically going to give you a bit of an overview on how you should be approaching your fish passage projects, and certainly the approach that we would generally take for if there is such a thing for a typical fish passage project. Obviously they're all quite specific in their nature, so they can vary a little bit, but this is the general approach that we're going to run through and how we think they should be taken on. So what do we mean by fish passage? What I'm talking about here is the movement of fish into, out of, and within water bodies, typically rivers. Sometimes it might involve lakes, or reservoirs, or these sorts of things when we're looking at fish passage. It could involve estuaries, which are at the bottom end of rivers, but predominantly we're looking at river systems. And I think it's important to mention that we also need to talk about both upstream and downstream passage. I'll come on to fish life history strategies in a couple of slides time. Most fish passage projects tend to focus predominantly on upstream passage, but we do need to factor in that downstream passage as well. Why is fish passage important then? Why do we need to think about fish passage? It's all about habitat connectivity. So fish, different fish species at different stages of their life cycle require access to different types of habitats. So they generally don't stay in the same place all the time. And that means they've got to be able to move between those habitats. And that's what we're talking about when we're discussing fish passage. It's the ability of those fish to move between and access the different habitats that they need at different stages of their life. A key driver for these movements is often spawning. So when fish are looking for places to undertake their spawning activities, and you have fish with different types of life history strategies in terms of that. So you've got two broad categories, are diadromous fishes and potamodromous fishes. The potamodromous fishes are ones that spend their whole life within fresh water, so within one river system, one river catchment, for example. They don't ever go out to sea or anything like that, but they still need to move within those river systems in order to access spawning grounds or feeding grounds or refuge areas. And then the diadromous fishes can be split into anadromous and catadromous. So that's either they're moving up into fresh waters to spawn, and then they move back out into the sea to grow up and mature, and then return again to rivers to spawn. And then there's fish that are the other way around. The first example I just mentioned, a species like salmon or sea trout. And the other way around is an example is the European eel, which will migrate down into the sea as an adult stage or when it's maturing, and it will travel across the oceans to spawn out in the sea, and then it will make its way back up or back across the oceans and back up into our rivers where they mature. So as I said, the reasons that they do this, the spawning is one of them. There's also feeding, so fish will make movements, sometimes quite localized movements, other times they might be much more prolonged within our river systems for feeding, to seek out refuges, places to hide, both from predators and also during flood flow events. And linked to that flood flow events is displacement. So if we get very high river flows, it might be that fish get washed downstream to places where they don't want to be, and they want to make their way back upstream. And if you can imagine during flood flows, you've got a big weir, you could find fish being washed over the top of that weir, and they then need to try and find that, or they want to try and find their way back upstream, but there's a dirty great weir in their way and they're unable to do that. So that's where we would start looking at fish passage issues. And it's also important from an ecological point of view for the wider river systems. Fish act as transferers of energy, so they're as they move between the sea and rivers and up and down rivers, they're moving energy within that ecosystem around. So another reason why fish passage is important, it's not just because we want to help fish because we're all nice and we all love fish, but there are also statutory requirements. I'm not going to dwell on this too much because it's the bit that I think a lot of people find the least interesting, but it is important because it can be one of the main drivers for fish passage projects. Probably the three main pieces of legislation that we need to think about are the Salmon and Freshwater Fisheries Act, that predominantly focuses on migratory salmonids. So if your river doesn't have migratory salmonids, so that's salmon and sea trout in it, then this one probably won't apply to you. But if your watercourse has eels in it, or should have eels in it, then the eels regulations will come into play. And there's also the Water Framework Directive, which is very much focused on achieving good ecological status or good ecological potential for heavily modified water bodies. And one of the key components of that, one of the key biological components, is fish. And one of the things that can significantly affect the fish component achieving good ecological status or good ecological potential is the presence of barriers to fish migrations. So what are the different types of structures which might cause problems? I think it's important to look at this because it's very diverse. There are a lot of different types of structures which might be affecting whether our fish can get to where they want to. This is quite an extreme example of a natural barrier, so something that's naturally occurring. This is a waterfall. This is Murchison Falls on the Nile out in Uganda, and you can imagine not many fish are gonna find their way up past that. But there are smaller falls, smaller cascades, natural debris dams. These sorts of things can cause problems. When we're looking at fish passage projects, we generally don't focus on these naturally occurring structures or naturally occurring barriers, unless there are human activities which are making them worse. And I'll come on to abstraction in a minute, which is one of those. There are dams such as this one in the Eland Valley. If you've never been to the Eland Valley, I recommend it. It's quite a phenomenal piece of engineering, seeing these dams. And I only found out recently that the Eland Valley that supplies Birmingham with its drinking water, and it's all gravity fed. So because of the difference in altitude, water can flow by gravity all the way from the Eland Valley in the sort of mid to west of Wales, all the way down to Birmingham, which is quite phenomenal. But again, a dam like this, you can see there's no option of fish migrating their way up past something quite as extreme as that. Weirs, we will come on to weirs on another slide, just where I'll show a couple of different examples. They come in all sorts of shapes, sizes and forms, and each one represents its own difficulties for fish, depending on how that's constructed and what shape it takes. But yeah, weirs are a big problem and probably one of the biggest focuses for fish passage projects. Boards, these can often be overlooked by people because they're not a big structure, they're not particularly tall, they don't have a huge head loss or something. I'll come on to head loss in a little while, but they can end up with quite shallow water depths and sometimes quite fast flowing water across, and it can simply be that water is too shallow for fish to navigate their way over. And even if it's not too shallow and they are able to swim, they're going to still be in relatively shallow water, and that can expose them to predation risks as well. So fords can be a bit of a problem. Culverts, there's a whole host of things that can affect whether culverts are an issue for fish or not. Pardon me. If they're perched at one end, so if there's a drop, then it might be that fish can't actually make their way up into them. If the water is very shallow or particularly fast flowing, velocities might be too high for fish to swim against, or the water depth, again, similar to the ford, might be too shallow, so fish can't migrate their way up. And there's also a behavioural component to that, which I'll touch on again in a minute. There are sluices up and down the country that we've used for controlling water, either for irrigation purposes, so water resource demands, or perhaps for flood control. But the sluices, obviously, if they're completely closed, you can imagine why that would be a barrier or an issue for fish passage. But even if they're open, the velocities through them or the gap sizes might be insufficient to allow fish to make their way through. Hydro schemes, so we're all for green energy. We'd like to see more green energy, whether that's solar panels, wind farms, or even hydro schemes. But in certain circumstances, hydro schemes can be a big issue for fish passage. They can, if you're building a new structure, that can create a physical barrier. There can also be issues associated with entrainment or impingement on screens and these sorts of things. Abstractions, so entrainment and impingement. This is a site that I've actually worked on previously for a previous employer. This is at just outside Monmouth on the River Wye, which is a lovely river for those that know it. So where we're abstracting water, whether it be for drinking water or cooling water intakes, for example, on power stations, it might not necessarily represent a physical barrier, but there are fish passage issues in that fish can become entrained into those systems or impinge on the screens that are there. So we sort of lump that in with fish passage. And this one here, low flow. So this is quite an extreme example taken out on a project that we did out in Greece. I was quite nervous when I took this photograph because there was fresh bear scat and bear footprints in the dried mud around the river. So we were keeping one eye over our shoulder in this area. But if we have particularly low flows, whether that is caused by drought conditions or over abstraction, that can reduce the depth of water within rivers. And it might be that if we've got shallow gravel riffles, for example, that they end up too shallow for fish to be able to move past them, in much the same way as we were talking about for fords earlier. And the last one on this list here, I should say this list isn't exhaustive, it's just an overview of the main ones, but I've got another culvert example here that I'm using to illustrate behavioural issues. There are some species of fish that won't surpass structures or certain areas of stream for behavioural reasons. So I put this culvert here because this is an example for salmonids. Salmonid species don't really like entering dark places. So if you've got a particularly long, dark culvert, it's not to say that they'll never go past it, but it can just delay them. And if you remember, I talked about some fish entering freshwater. So if we take the example of the salmon, when that comes out of the sea and enters freshwater and starts making its way upstream to spawn, it doesn't feed from that point onwards. So the whole time that it's in our river systems, it's not eating. So it's surviving purely on stored fat, stored energy reserves. And it needs to have enough energy to make it up to its spawning grounds and then do what it wants to do when it gets there. Any delays to that migration are just meaning it's using up some of those valuable resources that it might need when it gets to the end of its journey or to power it on through other parts of its journey. So if we create situations that are, even if there's no physical barrier and in theory fish can go past, if it causes them to hold up because they're a bit wary, a bit nervous of entering, all the time that's impacting on the fish and it can prevent them actually being able to complete their life cycle to get up to their spawning grounds. So behavioural barriers do need as much consideration as physical barriers as well. So I've been talking about barriers. I sort of see barrier assessments with two different approaches. There's the, if you like, the official formal approach, which is now generally taken to be the sniffer WFD 111 approach that was co-developed by guys from the Environment Agency and Southampton University. And this is generally the method that's accepted by regulators. So if you want your barrier assessment to be formally approved by regulators, they're going to want to see some numbers associated with it to show that you have actually investigated this properly, particularly if you're approaching it from the view of you don't think it's a significant issue. And if that's the case, if you're dealing with regulators, we'd be recommending you using the sniffer WFD 111 approach. The other option is if you just want an idea, if you get somebody who's experienced at undertaking barrier assessments and fish passage assessments and knows their fish well, knows the different species that might be present, you can get them outside and they can use their best professional judgment to give you an idea. I call it the quick look see, and we do that with some of our clients. So we'll get somebody out on site to have a quick look. They'll take into account some of the different things I'm going to show you in a minute, so water depths, velocities, that sort of thing, and they'll give you a view on whether it's likely to be an issue or not. So that can be quite useful if you're in the very early stages and you don't want to spend an awful lot of money before you figure out whether this is something you're going to need to look at in the future or not. But if it comes to that formal approach, you're going to be submitting paperwork, etc., you want to adopt that sniffer WFD 111 approach. It's a little bit more expensive because it takes a bit more time, but it does give you the numbers and values that your regulators are going to be looking for. So what are the main considerations when we're doing barrier assessments? One of the first ones that we consider is head loss across the structure. So that's the difference in the, if you like, the height from beneath your structure to the top of the structure. So the top of a weir down to the toe of a weir, or usually you're looking at the water levels between the two when you're talking about head loss. The bigger the head loss, usually the more difficult it is for species to pass it, so that's an important one. But there's another factor linked to that, which is water depths. And that can be from two different perspectives. So there's water depths over the structure as well. If you've got a sloping weir face or a ford, for example, there needs to be enough depth of water for fish to be able to swim through that. So if they've only got a centimetre or two, and you've got a fish, I don't know, a large adult salmon, maybe a 50, 60 centimetre long fish or something, it's not going to be able to get purchased with its tail to be able to swim through such shallow water depths. The other issue is the depth of water beneath the structure. So salmon are, I keep going back to salmon, apologies for that, we could talk about trout as well. They're incredibly athletic fish, and they can leap quite significant heights when they go at it. But in order to do that, they need the room at the base of that structure to power up, to be able to turn and get a run up, a bit like an Olympic athlete taking his run up for the long jump. Fish need the same. They need a bit of a run up to be able to power up and get the speed up so they can make that leap. So even if you've only got a structure of, say, I don't know, 20, 30 centimetres, you might look and think that's not a particularly significant issue. And certainly if there was a couple of feet of water beneath it, that might be the case. But if you've only got a couple of centimetres depth of water, then fish aren't going to be able to get that power up and that run up that they need. So water depth can be quite a significant one. And obviously that's affected by things like abstraction and rainfall as well. So during drought conditions, or if rivers are over abstracted, then that can affect water depths, which can increase the severity of those issues. The length of the structure. So fish have, broadly speaking, two ways of swimming. There's their endurance swimming, which is something, if you like, that's them going for a slow, gentle jog, and they can keep that up for quite a long time. And there's also their burst swimming or sprint swim, if you like, and they can keep that up for only a short space of time. So if you've got a particularly long structure, I mentioned culverts earlier, if you've got a culvert with quite fast flows through it and they've got to swim pretty hard to be able to get past those flows, if that's too long, they're just not going to have the physical capability to be able to do it. So the length of the structure can be quite an important one. We've got this adherent and non-adherent flows. The next point in the picture at the top left of these pictures that you can see how the water sort of spills over the edge and there's that air pocket behind it. That's what we call non-adherent flow. So it's not sticking to the surface of the structure. And you can imagine if a fish takes a leap at that and it lands in the falling water, it's got no purchase there to be able to swim up and power the rest of the way. Certainly if you take a look at salmon and trout, when these species are leaping, they'll often do a first sighting look first, try and gauge where the crest of that structure is, and then they'll have another one or two or sometimes multiple leaps to try and aim for that crest, and they usually power up the last little bit. They don't tend to leap right over the tops of structures. So if you've got that air pocket, when they fall, they just fall through and they're falling into thin air and they're not able to do it. Adherent flow is where the water is actually stuck to the weir. So the one on the middle right or the one on the top right, you can see the water is sticking there, and perhaps some fish would be able to power up through that. Middle right photo again, that's illustrating turbulent flow, so that can disorientate fish if they're getting bashed and boshed around, flipped upside down, turned around. If there's lots of bubbles, that can cause them to become disorientated, or I mean, they just can't align themselves to be able to power up. So turbulent flows can be an issue. And this last one, fish species and life stages, there are kind of two main issues with this. We've talked about the behavioural one before, so some species have different behaviour. I mentioned about the salmonids not wanting to migrate into dark spaces, but you've also got species like barbel, for example, don't particularly like leaping structures. So if they've got even just a small jump to do, it's not normal for them to undertake that behaviour. So it's not to say that they'll never do it, but it's an issue for them. They don't particularly like it. And also different fish have different swimming abilities. You can imagine a very powerful fish like a barbel or a salmon or a trout might be able to swim very fast and maybe do some of these jumps that we've talked about. Whereas if you take something like an eel or a bullhead or a stone loach, they're perhaps not able to swim quite as fast as these species. So the swimming abilities of the different fish species, and of course different life stages as well, can affect how big an issue a barrier is. So moving on to fish addressing fish passage then. So we've decided that we've got barriers, we've got an obstacle or a barrier to fish migration, we need to do something about it. This approach that I've just outlined here is generally the approach that we would take, and it's the approach I would recommend for most people. Is when you're considering your fish passage options, you start with the first question of do nothing. You know, is it actually worth us doing something here? What are we going to achieve by resolving fish passage? So before you even look at what your fish passage options are, it's important to ascertain, if we do enable fish to migrate past this structure, what are we going to achieve by it? Are they actually going to get access to decent habitat? How much habitat they can get access to? And that information is important even if you do decide to do something, to sort of figure out the benefits relative to the cost. Fish passage projects are not cheap. They are quite expensive, generally speaking. So it's important to know what the benefits are that you're going to get. Generally speaking, we do want to do something though, so we move on quite quickly. And the gold standard, if we do have a structure, is remove it. Get it out of the river. If it's concrete or steel or whatever it is, get it out, return the river to a more natural state. That is the gold standard. That's what we want to do every single time that we have a weir or a dam or something like that. Unfortunately, it's very rare that we can do that. And similarly, it's very rare that we can go for partial structure removal as well. A lot of these structures have existing purposes or historical value, and that means that we're not allowed to remove them. The next best one after that, the one that people claim gives you the biggest bang for buck past after full structural removal, is naturalized bypass channels or nature-like bypass channels. And this is pretty much what it says on the tin. So you basically create a new channel, a new river that goes around your structure, and you create it with a gradient that means the velocities are not too high for your fish to swim against. And the advantage of these is that you can create new habitat as well. So you can actually create refuge areas for fish, you can create spawning areas for fish. So that's why you can get an awful lot of benefit. They're not usually very cheap, they're quite an expensive option, but you do get a lot of benefits. And rock ramps can be a sort of shortened version of that, so a series of small rocky weirs, or they can be a sort of prolonged series of boulders going down a sloping face. And again, you can create habitat that other species, not just fish, but perhaps invertebrate species, diatoms, all of these things, they can colonize these areas and you get extra benefits. Easements are things like little notches in weirs or bulks. They're usually quite low cost, but they often only benefit one or two species. They're not generally all species things. And then the last one on the list is technical passes. So I've got a picture here on the left of Larinier superactive baffle pass. They come in a range of different forms. So you've got bottom baffle passes and side baffle passes. They work by the baffles dissipate energy to create slightly slower velocities so that fish can navigate those slopes. You've got pool and traverse ones, which are basically a series of pools with little weirs in between, usually with a notch in, so that fish can, you break down it into a series of smaller lumps. And you've got vertical slots, which again have weirs but with a slot down one side of them, and fish are able to navigate through those different slots. Okay, so I'm just aware of the time here. So the next stage after that, once you've done your options appraisal, you've come up with the idea that you think is the best for your site, is to undertake your detailed feasibility study and outline design. So what looks good on paper or after your first site visit may not actually be the best once you actually start working through the detailed feasibility studies. There may be issues or reasons why you can't progress. Full stakeholder engagement we would always advocate, so get the people who might have an interest in this structure, whether that's the local angling club, obviously your regulators, the Environment Agency, landowners, all of these people, water companies perhaps if they have an involvement. Engage them as early as you can. It just saves surprises further down the line when you've spent a lot of money on consultancy fees, etc. If something comes up and says, if someone comes along and says you can't do that, because get them involved as early as you can. You could even do that at options appraisal stage or at feasibility study stage. That's up to you. They'll often want to see outline drawings. It's one thing talking about it, but they want to see some pictures, outline drawings, so that they know what you're talking about when you're saying this is what we intend to do at your site. Quite an important one, flood risk assessment. If you're going to be changing something, you don't want it to flood Joe Blogg's house downstream. You will need to undertake topographic and bathymetric surveys, particularly if you're going to be changing something in the channel or adding a new structure in, the engineers, the people who are going to go out contracts and build it, they're going to need that information. The designers will need that information. You may need structural investigation. So if you're going to put a new fish pass alongside a weir, for example, you need to make sure that your work isn't going to cause that weir to collapse. So you might need structural investigations. And ground investigations, again, you need to know what you're building on. And linked to the ground investigations, you might want to check about utilities. You don't want to be putting your digger through somebody's electric cable or phone line. You need to check that out before you get to that stage. And just at the end here, I put in preliminary ecological appraisal. Again, it's worth doing this quite early. You can either do it at options appraisal stage or this detailed feasibility study stage. It's worth somebody going out and having a look around to see if there's anything else we need to be worried about. I'll hold my hands up and confess that prior to joining RSK, where I got surrounded by terrestrial ecologists, I would have looked at a culvert and said, that's not great for fish passage, let's get rid of it. I've now found out that culverts can be lovely houses for bats in some cases, so we certainly don't want to destroy bat homes. And we've got, you can see on the top left there, I've got a picture of one of my colleagues showing looking at some Himalayan balsam, Japanese knotweed. We need to think about these things as well. So have people go out and check on site and check there's nothing else, either invasive species wise or protected species wise, that we need to be worried about. And right at the bottom here, I've got a picture of a couple of crayfish. So we've got a white-clawed crayfish on the left and a signal crayfish on the right. I have worked on fish passage projects before where we were getting very close to deciding this is what we were going to do. We're going to install a fish pass that would have freed up improved connectivity. And that could have been taken advantage of by crayfish. And it turned out that we had white-clawed crayfish upstream of the weir and signal crayfish downstream of the weir. So had we done that, we could have caused a localized extinction of a population of white-clawed crayfish. So that project, unfortunately, was put on hold for a fish passage, but it meant we could protect white-clawed crayfish. So it is important to get that additional ecological information. Don't just focus on the fish. Once you've done that, the next stage is to move on to your detailed design. So you know that what you've got is the one that everyone wants, but then you've got to put your designs in place so that you can then hand that over to somebody who can go out and build your fish pass or remove your weir and reprofile the channel, whatever that's going to be. And you need to get people involved there who can do your hydraulic equations, calculate the velocities through your passes or through your channel. That may require some flow modeling. We always think artist impressions are good for dissemination to stakeholders. You may want to do that at the stage before the feasibility study stage. And once you've got your designs or whilst you're compiling your designs, particularly if it's a technical fish pass, you're going to need to complete an Environment Agency application for fish pass approval. Those go off to the National Fish Pass Panel. By the time you get this stage, you should already have local approval. You should have the buy-in from your local Environment Agency fisheries teams, and then they should be able to guide you on whether the Fish Pass Panel will approve it or not. But Fish Pass Panel approval is the sort of final stage of that. So that's a quick whistle-top tour. I just wanted to put this slide at the end of Future Fish Passage. There's lots of, Salmon and Freshwater Fisheries Act is still applicable, and you could find fish passage projects driven by that. The eel regulations is still quite a hot topic, and certainly there are still structures being looked at all over the country to address passage issues for European eel. But there's also this coarse fish passage regulations. Nobody's quite sure what this is going to be called, but this has been much talked about for several years now, and as we believe that it's ready to go to Parliament to be discussed and on the verge of being approved. But due to various reasons, including Brexit, and I'm sure the coronavirus pandemic has not helped, that's been delayed. But we are still being told by the Environment Agency that this is coming. And what that will mean is that instead of just looking at our structures for migratory salmonids or eels, as we have been doing in the past, people who own weirs or people who are abstracting water are going to now need to start thinking about all species. So I put coarse fish, it might be called all species. And all life stages, and that's going to have huge implications for the industry. It may mean that screens need to be replaced. It may mean that existing fish passes are no longer considered fit for purpose and will need replacing. So it's just something to be aware of if you do own a structure that could be creating fish passage issues, or if you're the owner or manager of a fish pass or an abstraction, that these regulations we are told they are coming. It's just a question of when, not if. And I think that's about the end for me. So hopefully that's given you a nice overview of fish passage issues and what you need to be thinking about in terms of fish passage projects. I think we've got a few minutes to run through some questions. So we'll hopefully some of you have got some questions to ask. If not, if you think of things after this, then by all means get in touch. You've got my mobile number there, you've got my email address there. So by all means do get in touch after this event and we can talk about your fish passage issues then.
Thanks very much, Pete. Fantastic. We have a couple of questions. We've got a bit of time for that, so we'll try and get through some of them. The first one is, do you think improving eel passages is the answer to the problems facing eel populations?
Yes and no is the answer to that, which sounds like a bit of a dodging of the question. So the issues facing eels are quite complex. Eel numbers, for those of you that aren't aware, declined massively compared to the 70s. They've declined by something like 95%. So there's a lot of concern about eels. Nobody's really sure what the reason is. There's a lot of reasons touted. Barriers to migration are one of them. Abstraction is another, so entrainment and impingement. Overfishing is another. Climate change altering oceanic currents is another issue. And nobody really knows what the main problem is. Almost certainly all of the things that people are discussing are a problem, and they should probably all be looked at as part of the solution or the way to help eels. In terms of eel passage, I think it's important to note that not all eels that arrive in our coastal waters actually migrate up rivers and spend their lives in freshwater. Some of them will spend their entire lives in marine environments, or perhaps dipping in and out of estuarine environments, maybe going up into the lower reaches of rivers, but they may not navigate all their way up. And for that proportion of the population, which is a significant proportion of the population, then these passage issues are not a problem. Eels are also pretty good at climbing. I've seen eels when I did a project out in Berlin. I watched tiny little elvers climbing the vertical glass walls of an aquarium, which demonstrated how adept these things are at climbing. So they will find their way over a lot of big structures. But of course, whilst they're doing that, they're exposed to predation or potentially exposed to the risk of drying out. You know, the last thing we should be doing is forcing a fish to come out of water, whether they're capable quite remarkably of doing that or not. In terms of will eel passes help? Of course it will. If we can make it easier for them to get to upstream habitats, that's only going to benefit. So I think barriers are perhaps sometimes overestimated for eels, but that doesn't mean that they're not an issue. I talked earlier about delays to migration, things like that. If eels are delayed, they can be exposed to predation as well. So by resolving those barriers to eel migration, we are certainly going to help eels. Will it be the thing that turns the tide and means that our eel numbers start to rocket again? Probably not, but every little helps, I think, is the main message.
Okay, thanks, Pete. We've got quite a few questions coming in now, so we'll try and do our best to answer as many as possible before we have to end. There's one here that says, how do you factor in temporal flow rates in the water, which might be exacerbated under climate change projections?
That's a good question. So within our rivers, the flow within rivers does change all the time, depending on rainfall and the associated runoff. Abstraction can, of course, affect flow within rivers as well. When you're undertaking these projects, what you need to do, so for most of our main rivers, you'll be able to get flow data, usually from the Environment Agency. Some of that is available freely online, other times you'll have to ask for it. And one of the things that we'll do is we'll create flow duration curves, and you'll be able to see what the water levels, what the flow rates are like at different times of the year. When you're designing your fish pass, you need to ensure that pass operates under as broad a range of flows as possible, ideally under all flows, but often that's not going to be possible. So when your clever guys are doing your flow calculations within that fish pass and your level calculations, they need to be aware of the species, of course, the target species that it's intended for, whether that is all species or just certain types of species. And that's where you'll need local knowledge of the fish species that are present. You may even need to do a fish survey to do that. but yeah, they'll need to factor into account that water levels and velocities will vary with different levels.
Okay, thank you. There's one here. Pete, the Environment Agency Fish Pass Manual is now 12 years old, but still commonly requested by clients as the main guidance document during projects. How relevant is this guidance nowadays, in your opinion?
I think it's still incredibly relevant. So I think we're not allowed to refer to the Environment Agency Fish Pass Manual anymore, though most of us in the industry still do. I think it's now the Institute of Fisheries Management Fish Pass Manual. I think they've adopted it. The Institute of Fisheries Management is the sort of fisheries equivalent of SAIM, I guess, in many ways. So they're one of our main industry bodies. The guidance in there is incredibly relevant. That's not to say that there aren't updates. So I would urge people, when you're looking at your Fish Pass projects, the Fish Pass Manual is an incredibly useful starting point, and certainly I still use it as a sort of go-to starting point for many projects. But what you do need to do if you're a good thorough ecologist or good thorough scientist is look at the species that you're dealing with and do a quick search. There's plenty of literature out there on fish passage issues and where things have and haven't worked. And there's no doubt, if you go up and down the country, there are some fish passes that have been installed with the very best intentions and they just don't work. And it's important to learn from those. And probably actually something that it's a good point. It's probably something I've missed from this slide. It's the next stage. Once your fish pass has been installed, is monitoring is so important. With so many projects that we do, things go in, installations get done, and this applies to terrestrial ecology as well. You know, you might install bat boxes, you might install refugia for newts, and it's the same for fish. You might install a fish pass. It's important to go back and check that it works. So some of the guidance in there may now be updated by other publications, but certainly as a starting point, I would say there's nothing wrong with that document. Just make sure that you're checking that there isn't new information to do that. I think that goes to science in general. Science evolves all the time, so we do need to move with the times and make sure that we stay current.
We certainly do, and that post-construction monitoring thing is something that we should do better at, I think, as an industry. Okay, a couple more, I think, and then we'll end. This is an interesting one in light of the sort of the current thing about rewilding. Do beavers and their dams create potentially cause fish passage issues?
Yeah, hot topic. Yes, they do is the simple answer. And there are quite a few debates about this, and I'm not really sure which one wins, if I'm honest. I'm certainly wouldn't consider myself a beaver expert. So if you remember when I first started, I talked about natural barriers. So waterfalls can be an issue to fish, and you do get debris dams, natural debris dams from falling branches, falling trees and things that can block river channels and temporarily affect fish passage. And I think that's exactly the same for beaver dams. They tend not to last forever. Flood flows will wash them out, but they'll come back and rebuild one either there or in a different place. There are a huge number of other benefits that come from beavers, though, in terms of the way that they can alter their habitats. And I think we've seen that in some quite dramatic cases where we introduce certain species that can really influence the habitat, sometimes in surprising ways. So the wolves in Yellowstone Park and the way that reintroducing wolves from predation could affect habitats was absolutely fascinating to see. And that's the same with beavers. There'll be a huge number of ecological benefits by them, by the way that they influence watercourses. There are also some potential flooding benefits, so they can slow the flow. You might have heard of this phrase. By holding water up in upstream areas of catchments, they can prevent flooding. But it can be an issue for fish passage, and I think that's the answer to that is still a hotly debated topic.
Okay, thank you. I think we'll just take one more question. This one is just wondering if you have any experience of issues with fish migration mortalities through turbines in hydropower facilities.
Yes, so it's been a few years now since I've been involved in a hydropower project. I did a presentation probably 5 or 6 years ago now about passage through, it might even be longer than that, about passage through turbines or fish friendly turbine options. hydropower schemes can be a problem, but there is technology being developed all the time, and there's technology available now which minimises that risk to fish. I've yet to be convinced of anything that is 100% fish friendly. I think all turbines still pose some risk to fish, but there are options. So there are Archimedes screw type turbines, particularly ones that have been retrofitted with dampers and baffles and things, had their leading edges doctored that can reduce the impact. But I think every hydropower scheme has to be looked at very carefully to ensure that if there is any impact, that impact is minimised.
Okay, thanks very much, and thanks everybody for all your questions. As I said at the start, any of the questions that we didn't get around to today, we'll get back to you on email, or Pete will. So just finally, I just need to say thank you everybody for attending today, and yeah, we really appreciate the interest that's been shown across this series of First Thursday Club webinars. If we could take time to fill in the questionnaire that we'll send back, the feedback questionnaire, that would be great. Our next First Thursday Club is on the 3rd of December, and that's going to be about achieving biodiversity net gain on site using the DEFRA biodiversity metric, and that'll be from Mark Line. So all I need to say now is thanks again, and we'll look forward to seeing you all then. Thank you.
Thank you, everyone.